4.3, this is one of my favorite sections because I love the algebra behind it, and this gets used in future math classes. 4.3 is tying together what we've already talked about, okay? We're still looking at polynomials. We're still talking about where they cross the x-axis. We're still talking about based on the degree of the polynomial, how many possible answers there are. If y'all recall, like a degree 5 polynomial can have how many possible answers? 5, 4, 3, 2, 1, or none, right? A degree 6 polynomial can have 6, 5, 4, 3. It's never more than, though, right? So if I gave you a degree 2 polynomial and you wrote 3 answers, something's wrong, right? Okay. 4.3. Let me ease you into it. Let me show you the roadmap before I throw you right into a problem. Refresh your memory on recognizing what's called standard form when it's multiplied out, and what's called factored form where you can actually see the factors. Get comfortable with that word, factor. Get comfortable with knowing that factors are directly related to the zeros, which is just the solutions, because it makes this so much easier if you can understand that. So, when a polynomial is in standard form, I can't see much about it other than, oh, this is a cubic, Saturday Night Fever, opening normal, right? That's all I can tell you. When a polynomial is in factored form, that polynomial in factored form looks like this. Now I can tell you it's a cubic because I see how many x's. 3. Make sure you know that. There's x, x, x. So the highest exponent is going to be x cubed. So that's how I know it's a cubic. I can also see immediately the zeros. Another word for zeros, and you're going to hear this word in this section, is called the roots. The word roots and zeros mean solutions and x-intercepts. They all mean the same thing, okay? What's the zero from that factor? -3. Let's put x equals -3. What's the zero from that one? What's the zero from this one? Okay. I am going to say, I'm going to make a little note. Be careful. I've seen people get so used to going from here to here. They'll say, oh, there's the factor, so there's the zero. So do you see the problem here? There's a 2 that's nowhere in my answer. So be careful. Don't get too used to the nice and pretty ones that when this one comes up, you forget, oh, you actually have to divide by that 2. Because it is going to come up now, okay? So just be careful. This would be wrong. I'm going to say it would not be -1. In that case, it would be -1/2. Okay, so the concept here is, y'all already know that if I have a polynomial in factored form, I can state the zeros. You already know how to do that. That was 4.1. We're going to reverse it. Imagine the song. Reverse, reverse. If I say, hey, the roots or the zeros are of a polynomial -3, -1, and 2. If I tell you that from the beginning, this is the point of today's lesson, you're going to go in this direction. You're going to say, oh, okay, well then, -3 comes from what factor? To get it, just solve, get everything to one side. So add the 3 over. That comes from this factor, right? What does -1 come from? X plus 1. And what does 2 come from? X minus 2. So if I say to you, here's a polynomial whose roots are these numbers, then you have to be able to say, then the factors are, and then it's ... what we just said. So we're going in reverse. Wrap your mind around that because it makes it so much easier if you actually understand it. If I say, here are the roots for the zeros, you can state the factors. If I say, here's the factors, you can state the zeros. They're directly related, okay? Now, going back to, I think it was 4-1. Remember when we had that polynomial? We had like f of x equals, and it was something really big, and it said check and see if 2 is a solution. Remember that? And I said, you just plug it in. You plug the 2 in here, you find f of 2, and if you get 0, then it is a solution. Remember that? Yes, that's where we're going. There is a new division that I'm going to show you. This slide right here, I'm showing you what's called long division. Because the next slide, I'm going to show you synthetic division. Do y'all know what synthetic means? Fake. Synthetic foods. Y'all hear me talk about it all the time? If something is synthetic, that means it's fake. Like my shoes. They're synthetic golden goose because they're fake, right? They're duck duckies. Yes. Hang with me on this slide because this is the long division to make you appreciate the fake division, okay? And you do have to know both because there's, where we're going in the next section, you have to be able to do long division. Fake division is very helpful and it's used more often. But there is one thing that we are going to do in the future where you have to be able to do long division. So, from the previous section where I said, hey, check if 2 is a solution. You just plugged it in, you saw if you got 0, and that's where you knew. Yes. Now they're going to say instead of checking if -1 is a solution, they're changing the phrase, check if x plus 1 is a factor. But remember they're connected. So there's 2 ways you can do this. You could pull the 0 from that and just plug it in, and then you would know your answer right away. But you still need to be able to do the long division because of where we're going in the future, okay? So, the tie-in here, determine whether, and I like to put parentheses around it, x plus 1 and x minus 3 are factors. Okay, well, in the back of my mind, I'm going to say to myself, if they are factors, then that means -1 is a solution and 3 is a solution. So I could check that from the beginning. We're going to use long division. It's called long division because it's the long way to divide. And you're going to remember this from 5th grade, maybe. There's a lot of writing. I need you to draw a line to separate because we've got 2 problems here. Here's how you set it up. The factor you're going to check goes in the front. You've got your little doghouse division bar. The polynomial it's dividing into goes underneath. That's how you set it up, okay? So over here, we're going to set up, we've got x minus 3. Now, this particular problem has no gaps because the very first one out the gate, I don't want to put one with gaps. But I need you with a highlighter or a colored pen to make a note. And I'm putting it in red because this is like red alert. If you forget the gap, you're going to get the wrong answer. You need to check for gaps in exponents. You have to check for gaps in the exponents because if there is one, you have to put a 0 for the gap so you don't get the wrong answer. Now, in our particular polynomial, it counts down 3, 2, 1, none, so there's no gaps. We will have an example, I think, yes, our next example has a gap, so you'll be able to see what it looks like when there is. All right, here's where the hard part comes in. I need you to put your pencil down and watch me do this because it involves me pointing to something with my left hand, writing with my right hand, talking out loud with my mouth. You're going to do the same thing when you're doing it on paper. You're going to like point to one thing and, go to with your other hand. That's how you do long division. It's a matter of multiplying and adding. That's all it is. It's just what do you multiply, what do you add, and that's where I lose people. Don't forget what the whole idea is. The whole concept is, let's do something simple. 4 into 48. The whole concept is, I need to divide the number into a bigger number, right? And produce an answer here. So that in the end, 4 times that answer gives me 48. Same thing here. I need to divide this factor into this polynomial so that at the end, which we don't have to multiply it, but at the end if I wanted to, I could multiply the 2 together and I'd get that. That's the idea. You with me? Okay. So how do you do it with polynomials and letters? You say to yourself, you always focus your attention on the very first term. The second term is just along to the right. You say to yourself, x times what would give me x cubed? X times what would give me x cubed? X squared. You write it up here, you multiply that through the whole thing, and you write it underneath. So x squared times x is x cubed. X squared times 1 is x squared. Then you draw a line to remind you to subtract. Okay? Watch. Cancels. If it doesn't cancel, you did it wrong. 2x squared minus x squared is x squared. Then you bring 1 down. You got to have 2 terms.
Isn't it 2?
We're going to do x squared minus x squared. 2x squared minus 1x squared, right?
Yeah, it says.
Okay. Oh, I didn't write that.
I was doing the x squared minus x squared, and then I thought you just went down to 2.
Oh.
Add the 1 and then.
Yeah, it's just the coefficients. Bring this down. Now you repeat. Focus your attention on the first terms. X times what is x squared? Alright, positive x, right? So you have to put a plus sign. Repeat, multiply that, just that, through here. What do you get? X squared plus x. Then draw this line to remind you, subtract, subtract. You're changing the signs when you do that. Cancels. Negative 5x minus x. Negative 6x. Bring it down. Repeat. First terms. X times what is negative 6x? Negative 6. That only multiplies through here. What do you get? Negative 6x minus 6. Draw your line to change the signs. Right? Cancels. Cancels. Because I got a remainder of 0, that tells me, hey, that actually is a factor, and this is what you get when you divide into it. Now, I'm going to give you a second. What I would love for you to do, I would love for you to start it. Just start it. Try it on your own. Just start it. I know, and then I'm going to move. I know. All right, so you focus on the first term. You say to yourself, that times what would give you x cubed. You write it at the top. Then you multiply it through, and then you change the signs and bring it straight down. And now I'm going to move just in case you're starting to panic. Try it, though. So we have some little notes to take here. This at the very end, when you brought that last one down, you went through the last step, there was nothing left. This is your remainder. I'm putting an R here. This is your remainder. If you want me to put the R on the other side of it, doesn't matter. 0 remainder. I like to box in the remainder to remind me, that the whole goal of doing that was to say to myself that I got a 0 remainder. Here's what that means. So yes, what was it we used? X plus 1 is a factor. Now, in my math lab, they're going to ask you to type what you got after you divided it, multiply together, plus the remainder. So I'm going to show you what that looks like. So in my math lab, we'll put MML, your answer would be the factor you divided times what you got when you divided it, plus 0, because that was your remainder. And I'm putting an R above it so you know where the 0 came from. So that's how they want you to type it in my math lab. Okay, that was only one example. We got one more, and then we're going to the fake division, which you will appreciate because there's less writing and it's faster. Okay, so here's you another chance to do it. Remember, you're focusing your attention on just that first term. The second term's along to the right. It's always the first one you're saying, this times what, this times what. All right, so watch. You say to yourself, x times what would give me x cubed? X squared. You write it, and then just whatever you just said multiplies through the binomial, and you write it underneath. So that would give me x cubed minus 3x squared, right? Let me show you a little red flag that should come up. Let's say you're panicking, and you're multiplying through, and you get x cubed minus 3x cubed, and then you go and you try to do the math. What do you notice? Your exponents always should match, okay? So if you're starting to do this and your exponents don't match, you've lined it up wrong, or you've multiplied wrong, or you came up with the wrong thing here, okay? All right, so let me fix it. So multiply through. We've got x cubed minus 3x squared. Draw your line to remind yourself that you're going through and changing all the signs. So this is actually minus, and this is actually plus. And if you forget to change the signs, once again, you should notice that that first term doesn't cancel if you forget to change the signs, and it should cancel. All right, so gone. Add straight down. 5x squared. Bring this down. Minus 5x. Focus on the first terms. X times what gives me 5x squared? 5x, and that's positive. You should also notice that your answer goes down an exponent, right? Okay, now you're going to multiply 5x through that binomial. What do you get? 5x squared minus 15x. Draw your line, change your signs. First terms cancel. So that's 10x. X times what gives me 10x? 10. Multiply it through. Draw your line, change your signs. Did you get 24? Here's what a lot of people don't like about long division when they come to a remainder, because they feel off. That being a number other than 0 tells you that was actually not a factor. Now, in my math lab, so what we would say is no, x minus 3 is not a factor. But in my math lab, they still want you to type what you got so they know you divided it, instead of going the shortcut, which was plugging that number in at the very beginning. So in my math lab, you would still type the factor you divided times what you've got plus the remainder, which in this case was 24. Now, let's say you do this and you're really worried you got the wrong answer. Go back to what Mallory was saying at the very beginning. At the very beginning, what number could I have plugged into that polynomial to check and see if this was going to be pretty? I could have plugged -1 in, and I would have definitely gotten 0 since it ended up having no remainder, right? What number could I have checked here? I could have checked 3, and I'm pretty sure, can you do this for me real quick? Plug 3 in there. I'm pretty sure you get the remainder. I think it's 24. Pretty sure when you plug 3 in, you get the remainder, which would tell you, hey, that one's not going to be pretty. So you could have done that in the beginning to know, like when you go through this, if you